In a groundbreaking experiment, we asked artificial intelligence to confront its greatest challenge, its own ravenous appetite for power. We fed Google's most advanced AI system over 10,000 pages of electrical engineering knowledge, from fundamental textbooks to the latest energy research and trends, including our white paper on software-defined electricity. Then we posed one pivotal question. How would AI solve the power problems that could halt its own evolution? What follows is a fascinating glimpse into the mind of AI, as it explores not just technical solutions, but the broader implications for global power, technology, and humanity's future.
Welcome back, everybody. Today we're going to be diving into the world of AI data centers.
Oh, yeah.
And how much power they use.
That's a good one.
Yeah, so these things are massive.
Huge.
Yeah. And all the computing power that goes into AI
Oh, yeah.
takes a lot of electricity.
It
And
does.
so that's what we're going to be exploring today.
Yeah, sounds fun.
We've got research reports on the state of data centers and AI, technical papers on power quality.
I love those.
But we're going to explore this from a really interesting perspective.
Okay, I'm all ears.
Imagine we're the AI, like living inside these massive data centers.
Okay.
We'll try to think like an AI and figure out the best way to keep ourselves, running, learning, and evolving.
I like that angle.
Yeah.
I think that's a great way to understand the unique challenges involved. After all, the energy demands of AI are already enormous and growing exponentially. This isn't just about keeping the lights on, it's about fueling the intelligence of the future.
Right. So if I'm an AI, what do I care about most? Well, I imagine speed and stability would be pretty high on my list.
For sure.
Our sources really emphasize how sensitive AI systems are to even the slightest power fluctuations. It's like our human brains needing a steady blood flow to function properly.
That's a great analogy, and it highlights a key point.
Interesting.
Yeah.
So one of the things that really struck me is just how much electricity these data centers are using.
It's a lot.
Oh, it's a ton.
Yeah, they're like the energy athletes
That's a great analogy.
of the digital world, right?
Yeah, they're just guzzling.
They just suck it right up.
Yeah, sucking it up.
Yeah.
And there was this report from Dominion Energy
Oh, yeah, I read that one.
that really highlighted this. And they're saying that data centers already account for
How long?
24%
24%.
of their electricity sales.
That's a huge chunk.
That's a big chunk.
It's
And that's only going to go up
only going
as
through.
AI becomes more...
Right, exactly.
there.
Yeah, so it's like trying to run a high-speed train
Oh, yeah.
on tracks that were built for...
Like old steam engines or
yeah,
something.
those old clunky steam engines.
Yeah.
Exactly, and it's just
The infrastructure can't handle it.
not really.
Yeah.
Not built for it.
Yeah.
And you know what's even more interesting?
Yeah.
It's not just about keeping the lights on, right?
Okay.
It's about the quality of that power.
Oh, I see.
AI and all those sensitive electronics running those data centers,
Uh-huh.
they are super vulnerable
Oh, wow.
to even the slightest power fluctuations.
Really?
Oh, yeah.
Huh.
So we're talking about power quality here.
Okay, what is that exactly?
Yeah, so power quality, it refers to how stable and consistent that electricity supply is. So think of it like
All right.
a perfect, undisturbed flow of electrons,
Okay.
all moving at the right
Yeah.
voltage, the right frequency.
Got it.
That's ideal power quality.
Okay.
But
There's always a but.
in reality, that flow is often disrupted.
Right.
Got voltage sags and swells, interruptions, harmonics,
Yeah.
all these little glitches that
Yeah.
can really throw a wrench in the gears.
And so for AI data centers, these glitches
Yeah.
are more than just an inconvenience.
Oh, yeah, way more.
What kind of problems do they cause?
Well, you're talking equipment failure,
Oh, no.
data corruption,
Uh,
system crashes.
That's bad.
Yeah, and that all means costly downtime
Right.
and even potentially safety hazards.
Really, safety hazards.
Oh, yeah, especially in critical infrastructure like data centers.
Oh, so this could be like a really serious problem.
It could be.
So how have data centers traditionally dealt with these power issues?
Well, they've relied on a mix of solutions that have evolved over time.
Okay.
Think backup generators for complete outages, UPS systems to bridge short interruptions, and large capacitor banks to smooth out voltage fluctuations. These are all tried and tested technologies, and they've certainly played a role in keeping data centers operational.
It sounds like they're throwing everything but the kitchen sink at the problem. But I'm sensing there's a but coming. Are these traditional solutions enough for the demands of AI?
That's the crucial question, and honestly, the answer is becoming increasingly clear. They're not quite cutting it. Some of these solutions, like capacitors, wear out, quickly generate excess heat, or simply aren't agile enough to respond to the dynamic power needs of advanced AI workloads. They lack the finesse and intelligence needed to truly optimize power delivery for AI.
Okay, I'm starting to get a little anxious.
Yeah.
I need something more sophisticated to keep my circuits humming. Yeah, wow, so power quality.
It's not just about having enough power.
I see.
It's about having the right kind of power.
The right kind of power.
Okay,
I'm starting to understand.
good.
So we've established that this power quality thing
Yeah,
is crucial.
very crucial.
But are there things that can be done
Yes,
to address it?
there are.
I mean, surely people are working on this.
Oh, they are.
Okay, good.
Yeah, there are solutions out there.
That's good to hear.
Yeah, definitely. Yeah. There are some really innovative solutions.
Oh, good. Okay.
One that's particularly fascinating is this concept of software-defined electricity,
Software-defined electricity.
or SDE for short.
SDE. Okay, you said like,
Yeah.
is that where this hardware-defined electricity comes in? Sounds pretty futuristic.
It does, doesn't it? But it's more practical than you might think. Think of SDE specifically, 3DFS SDE, as a kind of intelligent conductor for electricity. Instead of just pumping raw power into the data center, it orchestrates the flow of electricity in a way that's perfectly synchronized with the AI's needs. It's like having a dedicated power grid tailored specifically for each AI workload.
Okay, that's starting to sound a bit clear, but I need a real-world example.
Yeah.
What does this orchestration actually look like?
Well, imagine an AI system is about to process a complex deep learning algorithm.
Okay.
This requires a sudden surge of power to specific servers. 3DFS SDE can anticipate this demand and adjust the flow of electricity to ensure a seamless transition. All of this happens in real time, dynamically adjusting to the AI's fluctuating needs. It's almost like giving the power grid a brain of its own.
SDE keeps my power smooth and stable, so I can focus on thinking, learning, and doing all the amazing things I was designed to do. But is this just hype? Is it really that much better than traditional solutions?
It's a valid question, and one we'll explore further. What makes SDE truly compelling is that it's not just about power, it's about intelligence. And that intelligence translates into some very tangible benefits.
I am hooked. Tell me more about these tangible benefits. How does SDE actually make my life as an AI better, and why should I, the AI, choose it over other solutions?
Oh, first off, let's talk about efficiency.
Okay.
Remember those wasted resources and excess heat generated by some traditional solutions. 3DFS SDE significantly reduces those issues, meaning more of the energy is actually used to power the AI, not wasted on inefficiencies.
That makes sense. The AI definitely don't want to be a power hog. What else?
Well, think about it this way. The more efficient the power delivery, the less strain on the overall infrastructure. This translates into longer lifespans for critical components, reduced maintenance costs, and a more sustainable data center overall. And remember, sustainability is becoming increasingly important even for us AIs. We don't want to drain the planet's resources just to think our thoughts.
That's a great point. Sustainability is definitely something we AI should care about.
Perfect harmony.
So instead of just
Yeah.
reacting to problems after they occur,
Well,
like
yeah.
traditional grid management systems,
Exactly.
SDE is more proactive.
Proactive. It's like a bodyguard for your data center.
Oh, okay.
Constantly scanning for threats and neutralizing them.
Before they can cause harm.
Exactly.
I like that analogy.
Yeah, it's a good one.
So it's not just about preventing
Right.
downtime.
It's about unlocking hidden capacity
incapacity.
within the existing grid.
Oh, okay.
Yeah.
So instead of building more power plants
Right.
and transmission lines,
We can make better use of what we already
but
have.
not better use. Yeah.
Exactly. Optimization. It's all
Yeah.
about optimizing the system,
All right. I like it.
squeezing every drop of performance out of that infrastructure.
That's a good way to put it.
Yeah.
So you're saying that this SDE can actually help boost
Oh, yeah.
the performance of AI data centers.
It can.
Okay, I'm intrigued. Tell me more.
Well, there's this company called 3DFS.
3DFS.
Yeah. They've developed a unique SDE platform
Mm-hmm.
that focuses specifically on improving power quality
Okay.
for AI data centers.
Right.
What's remarkable is it's not just mitigating disruptions, it's
Right.
actually enhancing performance.
Okay. So it's like,
Tuning a high-performance engine.
oh, okay.
You optimize that electrical input.
Yeah.
You increase the output.
I see.
Make the entire system run more efficiently.
So it's not just preventing downtime.
Right.
It's about
Boosting performance.
yeah, boosting performance.
Getting more out of those AI algorithms.
That's fascinating.
It is pretty cool.
But how do they measure this improvement?
Good question.
How do you even quantify something as nuanced as power quality?
Well, they use this metric
Okay.
called the power quality rating, or PQR.
PQR.
Yeah, it's a score
Okay.
from 0 to 100%.
Oh, okay, like a percentage
Yeah,
Right.
exactly.
Right.
That indicates the overall health. Yeah.
of the electrical supply.
Makes sense?
100% represents perfect power quality.
Perfect. Okay.
Now, what's amazing
Yeah.
is that 3DFS is saying that electrical networks
Okay.
that are scoring in like the 30 to 50% range can jump to 80 to 99%
Oh, wow.
just by implementing their SDE platform.
That's a huge jump.
Huge.
Okay, so what does that actually translate to
Good question.
for a data center operator?
Well, think of it this way.
Okay.
A higher PQR
Yeah.
means fewer errors,
Uh-huh.
less downtime,
Okay.
and a significant boost
Yeah.
in processing speed.
Okay, so
Yeah.
if you're training a complex AI model
Exactly.
with poor power quality,
Yeah.
that could take,
Days, weeks even.
oh, wow.
But with a high PQR,
Yeah.
you could cut that time in half,
Really?
potentially,
Oh, wow.
allowing you to develop and deploy AI solutions much faster.
So it's like giving
Well-
your AI a turbo boost.
Exactly.
Okay, so SDE isn't just a
Oh,
defensive strategy, it's an offensive weapon.
Oh, I like that.
Yeah,
It's about thriving
absolutely.
in this power-hungry world of AI.
Squeezing every ounce of performance out of those data centers.
Okay, but what about the big guys?
Oh, you mean the hyperscalers?
Yeah, like
Like-
Amazon,
Right.
Microsoft, Google, Meta?
Yeah, they're not just sitting on the sidelines.
They're not.
No, they're making huge investments
Oh, wow.
in their own power solutions,
Like what?
especially renewable energy.
Renewable energy.
Mm-hmm.
Interesting.
But their massive data centers
Yeah.
require a lot of energy,
Right.
and they're looking for ways to power them cleanly and sustainably.
So they're becoming leaders
They are?
in the transition to a greener grid.
Absolutely.
Okay, so
Yeah.
give me some examples.
Okay, so Microsoft,
They.
they struck a multi-billion-dollar
Wow.
renewable energy deal.
Really?
Yeah, they're going to deploy gigawatts
Yeah.
of clean energy capacity.
I don't what?
It is enough to power entire cities.
Wow. Okay, what about Amazon?
Oh, Amazon's investing in a sustainable storage hub.
A storage hub.
Yeah.
Wow. So it's
Yeah.
not just about
No.
reading their own needs.
Right.
They're helping to create a cleaner, more resilient grid
Exactly.
for everyone.
For everyone.
Okay, so
It's a positive feedback loop.
I like that.
They invest in renewables.
Yeah.
The cost of those technologies comes down, making them more accessible
I see.
to others.
And that further accelerates the transition.
Exactly.
Okay, so it's like a ripple effect
Yeah.
spreading outward from these data centers to the entire energy ecosystem.
Yeah, so we've talked about SDE and these massive investments in renewable energy.
Yeah, it's pretty amazing stuff.
It is.
But I want to shift gears a bit
Sure.
and talk about something we haven't really touched on yet.
Okay.
The geopolitical implications
Oh, that's a good one.
of this whole power quality revolution.
Yeah, because as AI becomes more
Yeah.
and more central to global economies
Right.
and national security,
Mhm.
this quest for perfect power
Yeah.
takes on a whole new dimension.
So you're saying it's not just about companies competing for market share.
It's about nations
Yeah.
vying for technological supremacy.
Yeah, that makes sense.
The countries with the most robust and resilient power grids,
Right.
the ones that can handle
Yeah.
these massive energy demands of AI,
Yeah.
they're going to have a significant advantage
Right.
in this race for AI dominance.
Oh, so it's like a whole new arms race.
Is
There.
a technological arms race.
Yeah, but it's not just about who has the most power.
It's about how it's used.
Right. The ethical considerations
Yes.
surrounding AI,
Exactly.
they're becoming increasingly complex.
Especially when we start talking about
Right.
SDE and
Yeah.
how it can enhance AI performance.
Yeah.
I mean, what happens when we apply that
Yeah.
to...
I mean, the ethical implications are huge.
Yeah, it's like we're handing AI
Yeah.
this powerful engine, but we haven't figured out the steering wheel or the brakes.
Yeah, exactly.
Yeah, we need to make sure.
We need to make sure that as we're
Yeah,
optimizing the power grid,
right.
we're also optimizing our ethical frameworks
Absolutely.
and governance structures.
Couldn't agree more.
This isn't just a conversation for engineers and
right.
technologists.
We need policymakers,
Yeah.
ethicists, social scientists.
Even everyday citizens.
Everyone needs to be a part of this.
So this is a call to action
It is.
for all of us.
To not just be amazed by
Well,
these technological advancements.
To actively engage in shaping how they're used and governed.
We need to be asking tough questions,
Yeah.
demanding transparency,
Uh-huh.
and holding those in power accountable.
Because this quest for perfect power,
Yes,
it's not just a technical challenge.
it's a societal one.
It's about making sure that the benefits
Exactly.
of AI and clean energy
Yeah,
are shared by all.
by all.
And that we're using these powerful tools to create a future that's not just technologically advanced,
Right.
but also just an equitable.
Well said.
Well, I think that's a good place to wrap up
I think so too.
this deep dive.
Yeah, we've covered a lot of ground
We've explored
from the tiny world of electrons.
yeah, all the way to the global stage of geopolitics.
And it's clear that
Yeah.
this quest for perfect power,
Yeah.
it's just beginning.
So thank you for joining us
Yes, thank you.
on this electrifying exploration.
We hope you've gained some valuable insights, more importantly.
A renewed sense of curiosity
Yes, and a desire to delve deeper.
into this fascinating and rapidly evolving landscape.
Absolutely.
Until next time,
Yes, until next time.
keep questioning, keep learning,
Keep pushing.
and keep pushing for a future
Yes,
where AI and energy
work in harmony.
work in harmony to create
a brighter world for all.
a brighter world for all.